I'm Jody Shear, and this is my communication project regarding Newton's law of cooling. Given this situation, we first need to figure out A, which was determine and discuss the value of K. To figure out K, I started with this equation here, which is given with the variables and the situation. Now I did take 98.6, which was assumed average body temperature, which would have been the body temperature at time of death. From here, I split the equation into two equations. I first started with this equation and solved it, leaving me with KT equaling this number. Then, after solving this, I came to this equation. I solved it all the way down and ended up with variable KT here. I was then able to take my answer for KT and plug it in for KT over here, being able to get K by itself. I then got K by itself, and K equaled 0.02315. This shows me the decay coefficient, which tells me how much time or how much of the body decayed after a given period of time. I therefore, after I got K, was able to plug into this equation KT. After plugging in K to KT, I was able to then get T by itself for time. I figured out that it was 45.48 minutes from time of death to the time the body was discovered. And B, when we wanted the time elapsed from death to discovery, we wanted it in tenth of an hour. So to convert minutes into hours, I divided by 60 to show me a part of a whole. I got 0.758 hours. To convert to tenth of an hour, I rounded up to 0.8 hours, which gave me T, which then solved for B. Then for C, we wanted approximate time of death. So for me, it's much easier to go for minutes and subtract from a time than it is hours. So I converted 0.8 hours back to minutes, which gave me 48 minutes. I took 7:30, which was time of discovery, and subtracted 30 minutes, which gave me 7 o'clock p.m. As shown here, I still had 18 minutes left, subtracted it from 7, and it got me 6:42 p.m., which gave me C, and the final answer to the situation, which time of death was 6:42 p.m. Thank you.